Here we see two examples of normal distributions. All normal distributions are bell-shaped, so both of these are bell-shaped, and they're symmetric around the midpoint. They go to zero but never cross the x-axis. On the x-axis here we have a random variable, and the random variable can take on values along the x-axis. To this random variable corresponds a normal distribution. That means that the probabilities of getting the different outcomes is distributed like this. So it's more probable to get it in the middle here than in the outskirts, or tails as you also can call them. The probability distribution is centered around the expectation value of this random variable. And that's always the case for a normal distribution. We also have here two inflection points. That means that the curve changes from being convex to concave or concave to convex. The distance from the midpoint to this inflection point is one standard deviation of this random variable. That a random variable is normally distributed, you write like this. The n means it's normally distributed, and here is the expectation value, and here is the standard deviation. A standard normal distribution is a normal distribution with expectation value 0 and standard deviation 1. Normally denote a standard normal distribution with capital letter Z. So the y-coordinate axis corresponds to expectation value equal to 0. And this distance corresponds to 1, to the inflection point. For all normal distributions, the probability of getting an outcome between the middle x value and one standard deviation to the right is roughly given by 34%. And the same for this. And the probability of getting outcome in this interval of x is roughly 14%. And the same here. So this holds for all normal distributions. A normal distribution is an example of a histogram, and that means that to read off probabilities, you need to calculate the area under the graph. That means, for example, that the probability to get an outcome of x between -1 and 2 is given by the area of this blue part. It also means that if you take the area of the whole graph, then it corresponds to 100%, or 1. So that's how we read off probabilities from a normal distribution.